here. Okay, so everyone, just to remind you, today and tomorrow, we are going to continue the idea of powers. I know we looked at it very quickly. Order of operations, we've spent a couple of days already. Tomorrow, I will look into simplifying fractions and whatnot, just to add it into the mix so that you're better comfortable with that. On Thursday, I am going to be, oh, sorry, I didn't show this. On Thursday, I am going to be giving you a formative quiz. That is simply put, feedback. To give you an idea of where you might stand. It's going to be designed like it was a real quiz. One page, double-sided, and you'll see how much marks each question is worth, or how many marks, sorry. And I will mark it for you, but it's not going to count. So you get a 0, that's fine. That's not going to count. However, it will tell you how much you know right now. So if you want to improve on it, that's your choice. If you don't want to improve on it, that's also your choice. It's formative information, formative. It'll also involve 2 of those questions are going to be leveled questions. So this might be new to you. It is going to be a single style, single concept, single skill that you're going to be tested, but it will be between levels 2, 3, and 4. In other words, I will give you 3 different versions of the same concept. It will be easy, medium, and hard. The hard one, you can earn a maximum, for example, 4 marks out of 4 if you get it right. Perfect. The medium question, even if you get it perfect, you'll get a maximum of 3 out of 4 because it's easier than the hard one. The last question, the easiest one, you can get a maximum of 2 out of 4. You can choose which one you do. Do not do all 3. You choose one, you do your very best, and I will mark based on that criteria. Yes, ma'am.
For the mock test, is it going to be like video or
Yes, it is going to involve all the prerequisite skills. That is BEDMAS, exponents, powers, and fractions. So we will look at fractions tomorrow and other stuff. You can use your calculator, yes. But you will see on the back of today, I am going to stress the idea of showing your work. And so there will be questions that says show your work as opposed to just give me the final answer. All right. Yeah, that's all I wanted to tell you before we get started. Any questions? This is on Thursday. Okay, so we still have today and tomorrow. Here we go. Starting with powers. Please read the question carefully. Some questions are a lot easier than you might think. Yeah, we'll grab a paper. Express each of the following products as powers. That means I want a base with a little tiny number as the exponent. All of that together is a power. With me? All right, 7 times 7. What will be the base? What will be the exponent? 7 is the base, 2 is the exponent. Done. Oh, I forgot. Done. I didn't ask you to solve. Show me that you understand the system that we use for powers. That's it. Go down the line. Ethan? 9, 4. Good. Someone from the 3rd row. Hey.
2 power 5.
Yeah. Someone for the Zoe? Yeah. I'm not asking you to solve it. And lastly, someone from Maya's row. Ellie?
1 power 2 power
1/2 to the power of 3. Yep, that's exactly right. Exponent shows how many times we're multiplying the same number by. Right, so that's it. Is another to actually solve it, in which case you can use a calculator. And I hope you will have a calculator by the end of this week, like your own. Yes, ma'am. Oh, I have it. I could have done this, absolutely, because 1.5 is together. I'm not sure why. Yeah, let me just have it. All right. The complete opposite. If you could do it one way, it only makes sense that you should be able to do it the other way. This time, all right, let's go. Madeline's row, someone from Madeline's row, I don't care who. Marshall? 6 times 6. Moving on, yeah, Maya? Yep. And you will see as we write this, it's annoying. Do you see why mathematicians invented a dot? It was a very natural evolution from an X to a dot, because in the math world, you use multiplications a lot and people got lazy, as typical, right? Why did I forget your name? Nolan, sorry, my bad. Next one. Yeah. Don't mean to insult your intelligence, so we're just going to move on. 2/3, 2/3, 2/3, and 2/3. Okay. From here, I want to challenge you of number 3. See if you could do this in your head. These numbers are small enough that I feel like you could be able to. And the better you are with mental math of these type of numbers, the better you are with recognizing exponential, I guess, answers, I think the better you'll be, especially in grade 11. It'll be a lot easier. No, just multiply, multiply, multiply. So a calculator comes in handy. 3 times 3. There is, but not in the grade 9 level. Okay. August says Ethan. Elliot, evaluate. Yep. Perfect. Moving on. Zephin, do you think you'd be able to do that for me? 2, 2, 2. Close. You gotta think differently when it comes to exponents. It is not 2 times 3. It's actually this. So this is 2 times 2 being 4 times 2, not 3 times 2. The answer is 8. Always keep that in mind. If you could do 2 times 2 times 2, Juan, you should be able to do 2 times 2 times 2 times 2. What is this? 16. In other words, from 2 to the power of 3, remember, 2 to the power of 4 is the same as 2 to the power of 3 times 1 more. That's 2 times 2 times 2 times 2. So you take this answer, you multiply it by 2, you get the same thing. It's all just a language. Don't think about it as memorization. Try to look at it lightly. I'm actually going to just leave the rest. I think you can do this on your own. And let's get to some parts that are interesting. Determine the exponent that makes each of the following true. I'm actually going to, one second. I'm actually going to go about this in a grade 11 way. Zoe, question or answer? Go for it. Come back quickly because I want you to recognize the format, okay? I want to actually rewrite the question mark as an unknown value x. And the proper way to show what's true or not is not just guess the question mark, but convert 128 into a power. What is 128 as a power? If you're not quite sure, here's how you could go about doing some guess and check. Ready? Where's my calculator? Okay, ready? 2 times 2 equals, not enough. Times 2, not enough. Times 2, not enough. Times 2, not enough. Times 2, times 2. Oh, there it is. I have to do 7 times. Confirm. I'll see. Welcome. 2 to the power of 7. Is that right? It is. 128 is the same as 2 to the power of 7. What does that tell you about x? If the left side equals right side, x therefore must equal a 7. We have no choice but to claim that as correct. That would be the method I would expect my grade 11 to do. And so I'm going to show it to you anyways. And I don't think it's something you can't handle. It's just a way of communicating. Let's try it again. 9 to the power of x is the same as 9 to the power of, well, let's try it. 9 times 9, I know that's 81, so it's got to be bigger than 81. Times 9. Oh, right away. It's 9 to the power of 3. Then I have no choice but to say that x is equal to 3. Yes. No, not necessarily. But again, we are creatures of habit. So try to write it in the same way that I do. So again, x to the power of 8. No, but it's just this format. It's a lot more complicated than this, right? But if it involves exponents, I would like this to be, just already embedded, so you don't have to worry about it in grade 11. What is 8 as a power of 8? Of basic, huh? Yeah, it's 8 to the power of 1. And so I know x is going to equal a 1. Woo. And here it is. Oops, I guess that's a question mark. What is that? What is 64 as a base of 4? That makes it harder, actually, I think. Really? Well, here's what I propose. If I had a number here, let's say I have a 2, that would be 1 over 4 times 1 over 4, right? If I had a 3 there, it's 1 over 4 times 1 over 4 times 1 over 4, and times so on and so forth. When you multiply across, I will always have a 1. But when I multiply across, how many 4s do I need to make a 64? So you can say, you can argue then that this is, right? 1 times 1 times 1 and 4 times 4 times 4. This is like saying 1 over 4 to the power of 3. There's a little bit of thinking for you. Why am I forcing you to do it this way? Well, it prepares you for number 5. Sure. Please express 16 in 2 different exponents or 2 different powers. In other words, in 2 different bases. And the same with 64. And see how multiplication table comes in handy. It's not just about memorizing, but how often you've used it, right? Give me one. Patrick, are you still with me? Yeah? I see you're working on some other things. It's fine, it's fine. But 16. Sure. 4 to the power of 2, because you know it's 4 times 4. What's another way? 1? Yeah. That's a 4. Right? They're all the same. It's just a way of expressing, which is interesting. Take a look. 4 times 4 is 4 squared. 2 times 2 times 2 times 2 is 2 to the power of 4. And that makes sense bedmass wise too, because if you noticed, 4 is 2 times 2. And this 4 is 2 times 2. You basically said the same thing. Right? About 64. Good. Yeah, a to the power of 2. Let's rewrite this, a to the power of 2. Or 2 to the power of 6. Or no. It would be 2 to the power of 6. Careful. 2 to the power of 8 is much bigger. Careful. Or 4 to the power of 3. That's right. Should I write it out? Let's try it. We've got 8 times 8, which is the same as 2 times 2 times 2 times 2 times 2 times 2, or 4 times 4 times 4. Does that work? Well, this 4 is 2 times 2. This 4 is 2 times 2, and this 4 is 2 times 2. However, if I were to break it up into 3s, 2 times 2 times 2 is 8, and 2 times 2 times 2 is 8. It's all the same. It's just a matter of expressing it. Okay. I'm going to leave you with number 3, number 7, and number 8. And when do I set you free again? 40, right? Let's do a quick break. I'm going to ask you to try these questions, and we'll reconvene with some more order of operation stuff at exactly 1:10. Question?
So for question 7, we just put like 4 to.
Yes. So let me explain for question 7. For question 7, if the power has this number, these numbers as a combination, it makes sense that the 4 is the base of my power. The 2 is the exponent of the power. And if I were to solve it, the answer is 16. Fill in the chart. Okay? If you want to move on and do the order of operation right away, you can. But I do want to spend a little bit of time doing it slowly to show you what I expect, at least for our quiz coming up. So I'll pause this here and let's give it a shot. All right, for the sake of the video, just wanted to show you what the answers ought to be. Please take a look at my explanation for number 8 as well. I know I talked about it before and the writing might be a little rough. I'll try to clean it up, but why are these two expressions not the same? So in short, I said for -3 to the power of 2, the negative is not part of the base. For this, the -3 is a part of the base. That's it. Being not part of the base, what is actually multiplied? Only the 3 is multiplied with itself. The negative comes after. For this, the -3 is multiplied again. That's all. You don't have to go into it. It's not part of the base. So the exponent doesn't care about the negative here. Very straightforward. All right. Again, you can take a look at the answer key and come up with your own explanation in your own words. You don't have to copy me, but understanding that idea will come in very handy. I may throw in a question on a quiz that's trying to, like, be all tricky with you and turn it into a trap. You better be careful. Yeah, so -3 squared is going to equal a -9, and -3 times -3 is going to be a +9. It's very different. I'll demonstrate this a little bit after. Again, for here, the negative is not a part of the base. You know how the base is being multiplied again and again and again? That negative is not a part of the base. So it's 3 times 3. And then the answer to that is multiply with the negative. Well, so -3 squared is the same as negative with a 3 being squared. The exponent only applies to the 3. It's not a part of the base. So that's a bit of a trap. Got to be careful. Okay. Yes, Andy. Yep, dead math still applies. Yeah. Well, yes, you could think of that. Yeah, you could think of that negative as is under the same. Yep. Yeah. You'll see. I think you'll see it in action when we do order of operations. Okay. People in the back, and Maddie and Zoe. Let's get through this. Let's get through this. When doing order of operations, I know I sort of briefly mentioned it yesterday, but this is what I mean officially. I do not need you to show me mini calculations on the side. The only thing I want to see is whatever's in here. Okay. 20 minus 2, bracket, 8 minus 5, close bracket, squared, plus 2 cubed, divided by 4. Please, you do not have to show me these mini calculations on the side and say 8 minus 5 equals a 3. Don't do it. Just write a 3 and I'll be like, oh, this person knows what they're talking about. Okay, I dealt with the fraction. Now it's time to deal with x. What did I just say? Back, Maddie. Sorry. So let's work on it after. Okay, let's finish the lesson and then you'll have time. Yeah. We've done the bracket. Now that we're done bracket, exponent, right? So let me just write this down. B, E, E, M, A, S. Work with all the brackets as possible. Now that we've done that, we're doing exponents. 3 squared is a 9. And then of course, after the 9, we have 8. After we do exponents, you go through the line and see if you can do multiplication. This is 18. That's a 2 as a division. Now that we're done that, this is 20 minus 18. That's a 2, 2, and that's a 4. I'll tell you right now, as you go through this and you become more comfortable, I could see you doing this in like 2 lines or 3, whatever, right? As you get more comfortable with this, you can do these very quickly, I'm not going to hold it against you. Yes.
Does it tell us what's with that on the beginning of it?
Yes, yes. If you want to skip a couple of steps, I understand. No problem. Okay, here's another one. Bracket first. That's a 3. Moving on. Let's simplify everything that we can without changing the value. 2 squared is a 4. And you know that minus a positive 3 is the same as subtracting a 3. Next, addition, subtraction, addition, and a multiplication. I am going to do multiplication first and copy the other numbers down. I'm not going to touch it. The reason why I don't touch it is because I am afraid that maybe I am not doing the left and right method, like I'm not going in the order I normally should. And so 7 plus 4, that's 11, minus a 3, and plus 12 is there. 11 minus 3 is an 8, plus 12, the answer is 20. And the rest of today is yours to finish your homework. But I want to do one of these questions because I want to make sure everyone understands BEDMAS and the nature of BEDMAS. Looking at this, the first letter is B, which stands for bracket. So we look inside the bracket to solve it first. What is inside this bracket? In terms of operation, a subtraction and, okay, so we need to solve the bracket first. How do we solve a subtraction and an exponent? BEDMAS again. So within the bracket, you still have to follow BEDMAS. So this line should be equal to, well, this is a 12, divide by a 3, plus a 9, 19 minus 9. The exponent comes before the subtraction. It is not 19 minus 3 and then squared. That doesn't make any sense mathematically. So please be careful. Even within the brackets, you have to follow BEDMAS. If there's a bracket inside a bracket, well, that bracket comes first. Does that make sense? Okay. Whatever's, every time you go inside a bracket, I guess BEDMAS refreshes and you got to do it from the start. Okay. Keep on doing it again and again. All right. The remainder of class, as usual, I let you go at 35. So sorry, I only left you 20 minutes today, but see if you can complete all of the questions that I left for you here, and we will take up any confusions next class. Please remember, mock quiz this Thursday. Okay.